4974. How should de-icing boots be used after exiting flight in icing conditions? A. Boots do not need to be operated after leaving icing conditions. B. Continue to cycle the boots several times to remove residual ice left behind after normal boot operation. C. Only continue to cycle the boots if you are concerned ice may continue to accumulate. The correct answer is B. After exiting flight in icing conditions, de-icing boots should continue to be cycled several times to remove residual ice left behind after normal boot operation. Therefore, option B is the correct choice. De-icing boots are designed to periodically inflate and deflate to break and shed ice accumulation on the leading edges of aircraft wings and tail surfaces. While the boots are typically activated during icing conditions, it is important to continue cycling them after exiting those conditions. 4969. The most hazardous aspect of structural icing is that A. It can cause breakage of antennas. B. It can cause blockage of the pitot tube and/or static ports affecting aircraft instruments. C. It can result in aerodynamic degradation, including loss of lift. The correct answer is C. The most hazardous aspect of structural icing is that it can result in aerodynamic degradation, including a loss of lift. Structural icing refers to the accumulation of ice on various surfaces of an aircraft, such as wings, tail, fuselage, and control surfaces. This ice accumulation can have severe consequences for the aerodynamic performance of the aircraft. 4970. Preventing ice from causing a hazard for aircraft certificated for flight into known icing conditions is accomplished by 1. Spraying alcohol or glycol solution on the aircraft before takeoff. 2. A de-icing system on the aircraft. 3. An anti-icing system on the aircraft. Which statement is true? A. All 3 statements are true. B. Only statements 2 and 3 are true. C. Only statement 1 is true. The correct answer is A. Pilots require an operational understanding of how to utilize the de-icing and anti-icing frameworks sometime recently flying suitably certified flying machine into known icing conditions. All of these explanations are genuine with respect to the lessening of the dangers related with ice. For Q4971-1, what is the purpose of a weeping wing? A. The weeping wing can be used in place of spoilers to slow the aircraft. B. The weeping wing provides leading-edge protection against icing. C. The weeping wing provides additional camber for aerodynamic lifting. The correct answer is B. The purpose of a weeping wing is to provide leading-edge protection against icing. Therefore, option B is the correct choice. A weeping wing is a type of wing design that incorporates a system of small holes or slots along the leading edge. These holes or slots are connected to a source of heated air or anti-icing fluid. When activated, the heated air or fluid is released through these holes or slots, creating a continuous flow over the leading edge of the wing. This flow helps to prevent or remove ice accumulation on the wing surfaces, providing protection against icing. For Q4960-1, what should pilots do if icing is detected while also experiencing a rolling condition? A. Lower the flaps to decrease airspeed. B. Set power and angle of attack for a controlled descent. C. Retract flaps and increase power. The correct answer is B. One risk of auxiliary icing is the conceivable uncommanded and uncontrolled roll wonder called roll disturbed, related with extreme in-flight icing. Roll disturbed may happen as a result of, or earlier to, a wing slowed down due to atypical strengths that cause the ailerons to deflect, or since the ailerons have misplaced adequacy. Avoidance of ailerons or misfortune of aileron adequacy may be caused by ice amassing in a delicate range of wing rearward of zones secured by wing ice avoidance systems.